As the use of technology and screens increase, rates for myopia or nearsightedness have also increased. Furthermore, for the past 2 years, COVID-19 has been forcing a lot of adults and students to transition to online workplaces and schools. Personally, I know people whose eyesight has declined since the pandemic began. The cause of nearsightedness still isn't clear today, but prolonged screen use and use of a screen with it being too close from the eyes can cause eye strain and even blurry eyesight. There are ways people try to prevent prolonged screen use and regulate distance, such as the 20-20-20 rule. Look at something 20 feet away for 20 seconds every 20 minutes of screen use. However, it can be easy to forget about the 20-minute limit when you're focusing on your screen. In short, self-control is an issue when it comes to eye protection. The purpose of my project was to create something that helps people be aware of time and distance when they're using a screen. I considered several ideas, including an app that makes you rest every 15 minutes or a timer intended to be placed on a desk, but these already exist. So I designed the gadget that does two things. One, warn the user when he or she is within 35 centimeters of a screen, and two, warn the user after 15 minutes of screen use. This project actually took a lot of designing, testing, redesigning, and fixing problems. The first thing I did during the process was preliminary design. My initial objective was to create something that regulates the distance between a person's head and a screen. So I decided on using a distance sensor unit connected to a sound unit to warn the user, attached to either the user's head or a screen. The second step was to find the parts of the gadget. At this point, I had a rough idea of how the gadget would work, so it was time to find the specific parts. I ended up choosing a lidar sensor, which uses a pulsed laser to detect distance, and an Arduino Pro Mini microcontroller board, among other parts. The third step was to create the code for the Arduino microcontroller board in Arduino language, which is basically C++ with modifications. The code allows the microcontroller board to control all the other parts. Next, I had to test the parts out individually to see if they work, and also figure out how everything connects to each other, because up until this point I had no circuit diagram or anything similar. This step took a considerable amount of trial and error. After that, I had to design and 3D print the outer shell for the gadget. Designing the outer shell was an important step because the shell has to be robust and also fit all the parts snugly. This took a while too because I had to redesign a lot of times. Then finally it was time to assemble everything. I used a soldering iron and soldering wire to solder the circuits together. This stage also took some time because I was completely new to soldering circuits, and at one point the soldering iron stopped working, so I had to order a new one. Lastly, after I assembled the circuits, I had to test the gadget's capability under different environments, including under bright sun, indoors, outdoors, at night, and more. I also tested how long the battery can last before it needs to be recharged by just leaving it on for a few hours and found that it can last 4 to 5 hours. Next, here's a short demonstration of my project. Here are the two halves of the outer shell of my gadget. And here is the assembled circuit. This is the battery, this is the touch button, this is the sensor, this is the charging circuit, this is the microcontroller board, and this is the buzzer. And here is the gadget itself. We can touch this button to turn it on. This gadget was actually pretty difficult to put together. The most difficult part of creating this project was probably figuring out how to assemble all the circuits because I didn't have much experience in circuitry before this. I overcame this particular difficulty by a lot of trial and error, and I can tell you it was pretty daunting. The finished product worked pretty well, but there are definitely possible improvements. One thing that can be added is different modes for the gadget. Right now, the gadget warns the user if the distance is less than 35 centimeters, between 48 and 50 centimeters, or between 90 and 100 centimeters. The reason there are different ranges is because a larger screen requires you to be further away. The 35 centimeter range is for small screens like phones or tablets. The 50 centimeter range is for medium-sized screens like small laptops. The 100 centimeter range is for large screens like desktop monitors. Basically, it tells you the minimum distance away you must be when using a screen of a certain size. In the future, I could add a toggle switch to toggle modes so that it only detects one range at a time. Thank you for listening to my presentation. Have a good day.